You're good to
Hello,
go.
everybody. This is Gordon Rosner, your president. Yeah, Tom?
I just said you're good to go. Sorry.
Okay. All right. Hello, everybody. This is Gordon Rosner, your current club president. And boy, do we have a special meeting for you all today. So we're going to jump right into this, and I'll be breezing through my section really fast because I'm all excited about getting these member presentations going. So we'll have the usual welcome and introductions, introduce the 2022 club officers that we voted on last time, and the usual club news, and then our special member presentations. So what are those special member presentations? Well, David Dunham, look at that recent occultation results, and we've got how to effectively use that monthly list by James. Alex is going to come in and tell us how to process data from the Hubble Space Telescope. Sid is coming in about automating astrophotography. John is how to build your own home Observatory. How exciting. This meeting, this end of the year, was instead of a main hour and a half long presentation, is to let the members tell us what they've been doing. And boy, we got some great ones this time. So let's see, as usual, welcome everybody. Hope everybody can live long and prosper. Farewell to our 2021 club officers. Remember, we voted on this last month, and it was unanimous. The plan was these people kind of shuffled around a little bit. These names will sound very familiar to you. The administrators did not change. They're still the same people. But all the other executive officers, and board members, they were open for new people. So welcome 2022 club officers. Our president next year is Claude Haynes. That name sounds familiar. He's been our Greco manager for years and years. The vice president still remains open, folks. So if you're interested in being one of the club's officers, let either Claude or myself know in the vice president position, and we'll get you going. Now, you have this great group of people that's helping you, so don't feel afraid that, oh, I don't know what I'm doing. We will certainly help you. Treasurer, Alex, that's a familiar name. She used to be a board of directors at large, and she now is our treasurer. I went over to being the secretary, and the board members at large, there's a new name showing up, David Koester. He's an old name in the club, so he volunteered, so he fit right on in there. But remember, the most important member of the club is you. Stay with us. Join us on these monthly meetings. Keep joining us. Club news, kind of the same old thing. Greco remains open, for private star parties. But look down there at the bottom. Due to the Repairing After Dark event in the holidays, Greco is going to be completely closed through January 1st. So keep that in mind if you were looking forward to some private Greco party, something like that. Yep. So club news are the usual club olds. Same thing, guys. All other EVAC personal contact events still remain closed. The board of directors gets together every month, reviews the situation, looks and sees is there anything we can do, anything we can open or what. And still, they voted on that we are still not doing any personal contact events. And we will review that again next month and every month until things get somewhat back to normal. Member articles. Remember, anyone who wants to be a published astronomer is submit an article. Next month, you would submit it to Claude, but via the president link on our website. And I'd be happy to include that in our monthly newsletter. And remember that these monthly meetings will be recorded. It is being recorded right now, and it'll be on our website. Give it a day or so if anyone misses it or wants to see it again. So our next meeting is Friday, the 21st of January in 2022. It'll be Dr. Steve Desch, ASU professor, School of Earth and Space Exploration, and the subject is Oumuamua. Couple ways of pronouncing that. I'll pronounce it as Oumuamua. And as you recall, Oumuamua was that interstellar or intersolar system object that passed by us that caused quite a stir a few years back. So he's going to tell us about that. And that will be interesting because, you know, this is one that had all the thoughts that it was some interstellar alien ship or something like that. So it's going to be fun to listen to an astronomy professional on what it actually was. So our Vice President, Tom Mosden, will introduce our member presentations, and I'm so excited. I want to get into this thing. So Tom, take it over.
All right, thanks, Gordon.
Sure.
Yes, we have 5 presentations today. They're 15 minutes in length each, and we'll allow 5 minutes for Q&A. So please put your questions into the Q&A. And our first speaker is David Dunham. He's talking about results of recent occultation observations, and no better person to talk about it than David. He was the founder and former president of the International Occultation Timing Association. So with those credentials, I'm sure we're going to all be excited to hear the results that David's going to give us, and maybe some tips on how to participate in the future. So go ahead and, let's see, I'll get you unmuted, David, and share your screen whenever you're ready.
Okay. Okay, here. Okay, everyone see the screen?
Looks great.
Okay. Okay, I'll start so that so I'm going to be talking about just 3 interesting occultation results that we've obtained during the last few months, and also one very interesting one earlier in the year, briefly. And then I'll be talking about, you know, how you might get involved in the activity. But this first slide, I just want to emphasize that occultations are not just of interest to just a few geeky amateur astronomers in the International Occultation Timing Association, our IOTA group. We collaborate with professional run groups with the Southwest Research Institute in Boulder, Colorado, and they are very interested in occultations for the Lucy project, the NASA mission going to the Trojan asteroids. Then Frede is also involved with RECON, the Research and Education Collaborative Occultation Network, stringing across the Western US 50 observatories that they've established just to observe occultations that happen to pass that area. And some of the TNO events and centaurs and the more distant objects they concentrate on. And then, but internationally, the Lucky Star project run out of Paris Observatory does a lot of work too. Going on to the next slide, this just lists the 3 events I'll be talking about, and then I'll talk about Arecibo, how earlier this year we discovered a large moon, and then I'll talk about upcoming opportunities, and then sources for predictions and observation help, and just a plea to we need your help to get better coverage of these occultations. So the first event is on September 15th that we did with a 7.2 magnitude star. It was occulted by the asteroid Camellia over northwestern Arizona. So I'll just go on to the next slide, showing how we set up 3 stations, 3 telescopes with video recorders and timers to successfully record these occultations with pre-pointed telescopes. Ted Blank did the same thing with 3 telescopes around Kingman. So we were north and south of Wikiup. And there were other observers also who set up single stations, or in a couple of cases, actually 2 stations. The next result shows all of the observations of the event, but on a smaller scale than that, a much smaller scale that you really can't see. This is the I guess I think you might be able to see my cursor in the lower left there, showing the Arizona observers. There were some in California and Minnesota. The green dots mark stations that recorded an occultation, while the red dots had misses. So anyway, next slide shows the results projected onto the sky plane of all of our timings. And what we usually do with these is we fit an ellipse, the best fit ellipse to the observations, which we've done in this case. And you can see it's an 83 by 51 kilometer ellipse, fits the observations, but not very well. You can see that the observations are very irregular, showing an irregular shape for this object. And with this bright star, normally when we have shifts like this, we suspect timing errors. And so we double down on the observers and say, well, how did you do this? Did you have a reaction time where you're observing visually and so on? But all of these observations were video with really tiny errors because the star was so bright. So what you're seeing here is actually the topography on the asteroid, very irregular shape, which we just didn't expect. And there were some astronomers who observed light curves, many amateurs even, light curves of asteroids, and then they deconvolve them to determine a shape model of the asteroid, but no such shape model is available for Camellia. I think these observations will spur those observers to maybe take a look at this asteroid, because something interesting could be going on. There could be a moon causing one of these things or something, a close-in moon. So it'll be interesting to see what the shape of this asteroid is for more observations. Next slide is the next event I'll talk about was on October 20th, an occultation by the Trojan asteroid 3548 Euripides, not Eurybates, it's Euripides, as the proper pronunciation. It was only a 13.5 magnitude star. Fortunately, it was close to a 5th magnitude star, 32 Tauri, so that made it a little bit easier to find. But there's great interest in this event because it is a target of NASA's Lucy's mission, which just happened to launch 4 days before this event. So some of the people from SWIRI had to be at the launch site, and then they rushed to Las Vegas to help with the deployment for this occultation. And the next slide shows the map that SWIRI provided the Southwest Research Institute to cover this event, to try to get the best possible coverage, but they thought that there could be some large errors, so they didn't want to cover just the nominal path shown between the two blue lines here, the north and south limit, but in case there was a big shift, which could happen in case the asteroid had a close-in moon. I mean, there was one previous occultation where they just got a couple of chords, which allowed them to predict the path pretty well, but if there was a close-in satellite, that would throw the prediction off of where it would be. So they wanted to try to rule it out. Fortunately, the star positions now are all really well known from the ESA Gaia mission, almost always well known. Some of the bright stars have some problems, but anyway, there were 37 lines, these orange lines across here, that SWIRI wanted to set up and wanted to occupy, and with collaborating with the recon people that they brought in from just normally they observe from fixed sites, but they packed up their scopes and equipment and drove to Las Vegas so they could deploy for this event, plus the SWIRI telescopes that were deployed, and then several IOTA people who, and they paid the observers travel expenses in many cases to get these people to come out there. And but they people had to make their own arrangements for the time. It was, at like 4 o'clock in the morning of a weekday morning. So people had to take that into account in their schedules. A lot of the recon people, they have day jobs. They work as, teachers and at community colleges and even high schools up and down the Cascade area. And so they had to, make some of their own arrangements. In some cases, they trucked equipment from stations that couldn't participate in for the people that could. And the Las Vegas Astronomical Society responded with help and got help from even local high school students came out to just provide help, logistical help for everything. And all 37 of these lines were occupied. Most of them were on US 93 north of Las Vegas, but there were a few people who went north from Flagstaff to observe it in northern Arizona. All the data are being collected by SWIRI, so we don't have most of the information. We just have some of the IOTA observations, and this shows the sky plane plot of the result. The prediction was fairly accurate. Joan and I set up 2 stations out on the wings, and that's shown down here in case there had been a shift, but there wasn't. So the observations definitely rule out that there's no large satellite messing up the way Euripides moves in its orbit around the sun. But these are just a few chords, but altogether there are at least 9 positive chords were obtained. Now, one of the observers here was Richard Nolthenius, who traveled from, was in the path, he was in Santa Cruz, California, but it was very cloudy there. And he drove all the way to Mono Lake, then about 250 miles, to get a chance of a break in the clouds. And he did get a break in the clouds, just enough to get the disappearance. And then just a second after the star disappeared, the clouds closed in on him. So he was very lucky to at least get the disappearance there. But with the other chords, we'll start to see the shape of this asteroid. So let me go to the next. The third object was a TransNeptunian object well beyond Pluto, of 42 astronomical units away, just discovered in 2002. It has about 550 kilometer diameter, and this shows the predicted path in the uncertainty zone. We had other reasons to be out back east during this event, so we participated in it directly. One of the lucky star predictions had a path farther south, but with larger error results. Their lucky star path was over Washington, D.C. The next slide shows, this shows the IOTA prediction where the path was up over the southern Great Lakes area. But all of the green dots observers who successfully recorded the occultation and timed it, and the red dots are people who had misses. And one of the red dots was ourselves. We were visiting friends in the Outer Banks in North Carolina at that time. And of course, we had a miss there. But we had a consolation prize. We got to see the Crew 3 module carrying 4 astronauts to the ISS, which launched about an hour before the occultation. We had one of our colleagues was out watching us, and he says, "What's that comet moving across the sky?" And we looked up and we saw this strange thing. We saw this object moving with this big parabolic arc behind it, and we were really puzzled. And so it must be some rocket launch or something. And yeah, sure enough, we found on the news that it was the SpaceX Crew 3. But the night before this occultation, we had observed another occultation from 3 sites in the Outer Banks, and that was quite successful. With 2 other observers in Arizona, southern Arizona, timed that event too. So that was just another thing. But the TNO object to get this great success. We were very happy and fortunate that we had pretty good skies there. This shows the sky plane plot of the observations. There were a few observations from Europe as well. Most of the Europeans were clouded out, but we had a record number of 150 observers who signed up to try this event on our occultation occult watcher tool tour, the largest number I think of any event we've had with that. But we got about 15 positive chords altogether to really get a good position, size, and shape for this distant TNO. In this case, remember the predicted was 550 kilometers. The best fit ellipse is 529 by 467. Going on to the next slide, I'll just talk a little bit about, this is the way IOTA should work and IOTA observers. Peter Noseworthy and Dave Gauld are two amateur astronomers. They have 10 and 14-inch telescopes in their observatories west of Sydney in the Blue Mountains in New South Wales, Australia. And they just observe from their observatory. They rarely do any portable work, but they observe this occultation by the asteroid Arecibo. And after the main occultation, sure enough, 3 seconds later, there was another brief occultation by both observers. But they were fairly close together, so they got good confirming results for each other, but weren't really spread out to get optimal data on the object. But alerting to the IOTA group to this, we looked and found that on June 9th, there was another occultation of a 12th magnitude star. It's only 13.3 or 13.5 magnitude star that they observed with their scopes, but there was a 12th magnitude star on June 9th. And we had these keen observers, Richard Nolthenius and Kirk Bender. Richard got one of the events on that Euripides occultation. But they both have portable 8-inch Schmidt-Cassegrain telescopes, and so and the proper timing, recording equipment, and everything. So I alerted them to this event. There was an event in Central California, about a little more than 100 miles south of their location in Santa Cruz. But they said, "Yeah, that sounds interesting. We'll try it." And sure enough, they got the occultation by the main asteroid as well, and showed very well it was about 24, just over 24 kilometers in diameter. And then they also, about 4 seconds after the main event, had an occultation by the moon, which showed that the moon is about 13.5 kilometers in diameter. So here they were nicely spaced, better than Peter and Dave Gauld. But so this gave great confirmation. We've tried a couple of occultations since then where we didn't see the satellite. It was just lucky that the satellites was in the path of the main occultation for both of those times on May 19th and June 9th to confirm that. But this is a case where Euripides, we were worried about the moon shifting the center of mass, and obviously this is a big moon, so the center of mass is somewhere almost maybe a radius away from the asteroid. We really don't know the orbit of this moon. We're really anxious to get more observations by this asteroid to see if we can get more by the moon. Anyway, that's the summary of the results. This shows occultation paths crossing Arizona during some of the brighter events in January and in February. There are one in March too, but that's beside the point. And keep in mind the dates are universal time, so often they occur the evening of the previous date, Mountain Standard Time, for instance, this January 1st event with Laurentia over Las Vegas area, nice bright star, 9.1 magnitude, but it's actually on New Year's Eve, December 30th, local time. All of the I've put all the objects that are 10.5 magnitude and brighter in bold here. Anyway, there'll be more about this in the notices that I send out and that we'll post on our website, which I'll show in the next slide. I just give a rundown of resources where you can get more information. The first thing you should, if you're interested in trying this, is to get George Viscon's occultation primer. He really has a good, description of what you need to do to make the observations and the equipment and everything the best ways. And also you should go to our Arizona Occultation Predictions website, the iota.huapl.edu/azox.htm. I always give the link in the messages I send out so you can pick it up from that. And we're going to post this presentation at this website so you can don't have to try to write everything down. You can just go to it afterwards. I'll send a message once we get it set up. And it includes Wayne Thomas's information and our list of upcoming planned events where we plan expeditions, and lists also for Computer for Greco for 2022 of asteroidal occultations within 150 kilometers, and also lunar occultation predictions. Another very useful tool once you get into this is the Occult Watcher that I mentioned before. This is the website where you can get the free software, and then you can get a list of occultations which pass over your observatory or within a range distance if you're mobile. And the main IOTA site is here, especially the observing pages, but there are lots of resources there. If you go to that, just occultations.org, that's easy to remember. And then finally, I don't have time to talk about it, but I've talked earlier this year about near-Earth asteroid occultations, which is rather a completely new field for us because they're very narrow paths. We actually successfully observed occultations in March and April by Apophis, which helped really pin down the orbit of Apophis enough to show that there's no chance of a collision of Apophis with the Earth during the next 100 years. So it keeps coming back towards the Earth. You need a really accurate orbit. And so each time that passes near the Earth, the errors magnify. But we've got the errors so small now that we know that there's no danger for a while. Especially important for near-Earth asteroid events are Didymos. Now, there are a number of occultations that are in 2022, and they'll be important for NASA's DART mission. And I have a dedicated web page for those events. And I have also a presentation on the near-Earth occultations. And finally, most important, we have extra equipment to loan that can be used with your scope to record occultations with your laptop. We need help from as many locations to better record these occultations. And we want you to join our expeditions or practice observing sessions when you can. We also have some small scopes for better events that we can lend. So that's the end of my spiel. I've probably gone a little too long, but if you can ask a couple of quick questions and get in touch with me, we'll answer what we can. So I'll stop my sharing now, and thank you for your attention.
All right, thank you, David. Yeah, we used up the full 20 minutes.
I'm sorry.
It's all right, but people can still put, we'll move on to James's presentation, but we can still put, people can still ask questions if they think about it, think of a question later on in the meeting. And of course, the slides will be posted on our website, or the recording of the meeting will be on our website. And so if you want to go if anyone wants to look at those links, they could go to the video recording and come up with the, you can view those links, or you just email us. Okay, well, thank you, David. And we'll move on to James. James is our property manager, and he also produces a monthly list of targets for astrophotography. So without further ado, let James take it away.
Thanks, Tom. Can you guys hear me okay?
Yes.
Okay, great. Yeah, I just went ahead and posted in the chat the website, or the link to my website, and also my email address if anyone wants to contact me or go to the website. I guess the first thing we'll do is, so I have been doing astrophotography for quite a bit of time, since college on and off. Yeah. And so I found that trying to plan a session, it makes it easier if I you know, see what objects are available and list it out, and then I can plan a session for the night, you know, way ahead of time and be more efficient. So I made up a list to do that, and I wanted to show you guys how to use that list. It's pretty straightforward, and some of the tools I've used to get there. So first, let me introduce you to the website here. Let me minimize that. I realize the screen might be a little small for you guys, so I'll try to enlarge it when I get to the PDF file. It's the ArtCentrics website. This is my own personal website, basically for just stuff I throw up here. So you can see there's a hodgepodge of information. There's real quick, I'll just step you through a couple of the more interesting things here. There's a hiking link here if you guys like going outdoors and stuff. I list all the hikes I do and then take pictures. And if anyone's interested in seeing the pictures of the hikes I do send out an email about once a week, and usually get 2 hikes in a week or so. So there's the hiking there. Over here on the center here, we have Money Matters, and that's another hobby I do, is kind of finance stuff for myself. And just as for your information, I realize most everyone's retired probably that's listening to this, but I am doing something at the beginning of next year about how to plan for retirement, see if you have enough money for your retirement and what adjustments you can make. So if anyone's interested in that, email me on that too. It's going to be probably a 12-week, you know, once a week meeting, and it's going to be going over a book that's a really good resource for planning retirement and in retirement. Finally, the most important thing that we're here to talk about is the astronomy down here in the middle, or to the left here. So we'll get to that in a short second here. There's also photography, astrophotography, deep space, and solar system objects. So if you just click on one of those pictures, it'll open up, you know, all the different stuff that I've done, and then you can select the thumbnail and see the full image. And the same with the deep sky stuff. Same thing. So that's how to get around in there. The astronomy link here is going to have a bit of information over here. First is the astrophotography, which I just took you there. This year's astronomical events. So at the end of the year, I try to figure out what's going to be happening next year. So if you click on that, and I'll go ahead and paste this address directly in the chat also. Let me pop that in there real quick.
Hey, James, if you maximize your web page, I think things might get a little bigger.
I'll try. I'm not sure. Let's see.
Far right, though.
It's a big screen is the problem. And I think it scales it. So hopefully that's helped. I'm not sure if that did any good. But
okay. Your choice.
But when we get to the PDF file, I can enlarge the font on that. So I will do that, but I can't do it on the, let's try that. Maybe I can do. Yes, I can. So there you go. So first thing here is just the apparent size of planets, and then come down here and list out each month what's going on, what I think are the interesting things that are going on. And also when there's a little icon like this, it'll show an image of what it's supposed to look like, you know, on your telescope or in the, you know, just the background and everything. So that's that information there. Back to the astronomy link here. So that's this year's astronomical events. Hardware is the hardware I use. And I guess while we're talking about that, so I do have a C11. That's initially I had a C8, but recently I've got a C11 that I use. The nice thing about these telescopes is that they are very configurable. And so we've got a hyperstar hooked up to it, you know, the primary focus, and then the focal reducer. So I get 3 different types of focal lengths on this, which is nice. And also it also makes my list a little more usable for others because they may not have the same theme, but they, you know, probably have a wider field view telescope that might be similar to my hyperstar or something like that. So the configurations I do the list with probably will match a lot of different people in different configurations. So that's the hardware, software, all this stuff is just more information type stuff. And then the astrophotography targets list, that's the month-to-month listing. So that's what this presentation is really all about here. So let's go ahead and click on that page. Scrolling down here, basically every month I try to keep a month ahead. I'll go ahead and make a list, and there's a white background and a dark background, and you can just click on it and download it, or it'll open and then you can download, or you can right click and save as. So what I did was save it. So let me go ahead and pull up the document. Actually, looks like I don't have that open. Let me get to it. Okay, and here's the document. I'm going to go ahead and increase the size on this too. Oops, that might be too much. Okay, and so this is for January the 2nd. So I usually will take the full or the new moon date for the whatever the monthly list is. And that for that date, I also find out what the sunrise is, sunset, the astronomical dusk, and astronomical dawn, so you can get an idea of what your amount of night sky you have. And also I list the configuration, focal length, field of views, and image scales. This is for mine, obviously. So this wasn't initially made to be a general for everybody. It was specifically for me. So take that with a grain of salt. You know, it's not going to be your system, but hopefully this will have some good information anyway. And then it talks about how to use it. And we'll just go ahead down to an example and talk to the various aspects of it. So here we list the object here on the top, and then the configuration for this particular image that I've got here, and the type of object that we're imaging. And here it's a galaxy cluster and the constellation that's located at, and the coordinates you can this image is centered on. And then also list a close star, a bright star, because a lot of times before I go to image the object, I'll first hit a bright star and do a focus on it and then go to the object. So I want something that's fairly close. And also when I have that star that's close to it, it will also, I can calibrate my location for the telescope. You know, when I go to it and plate solve it, then I can tell the telescope this is where I'm at. And so it usually is much more accurate at getting to the object that I'm looking for. And then the imaging window. So what I generally will take as the imaging window is 45 degrees is what I want has to be above the horizon. Now, if it has a star next to it, it means it's not going to be 45 degrees all the time, or maybe not at all. So that's something to keep in mind. So this is the imaging window for it, when it's going to transit for that month. Of course, that'll change day to day, you know, if it's not on the 2nd. And then the height in the sky it is when it transits. And then this is the image that you're going to see. So the actually, here's the catalog object also, this link here. This will take you to the Telecopus website. If you guys aren't familiar with that, I'm going to go ahead and show you that. Well, in a second, let me come back to that. It's a great website, and that's what I've used to get these images here. And if you put in your equipment and where you're located and everything, and you can get some really good planning tools there. It's really quite nice. So that's what these images are here. And like I said, each of the objects should have a link that you can just click on it and take you to that object. Now, if it's something I've imaged already, I will go ahead and highlight it in a different color. It's dark here. And then I've got the picture that I took myself here. So if you just click on the picture itself, it's going to take you directly to my website, and you'll see the image and then all the details on what I did to take it and how long the exposure was and everything else like that is in that. So that's kind of, to me, that's kind of nice, convenient for me to see what I've done, but also I guess I like providing real world examples of what you might get with a normal setup for people. Back to the form here. Okay, so that's basically how that works. I'm going to come back to the Telecopus website in a second here, but let me scroll down to the bottom real quick and get to the other part of it. So, and the way these are listed are by transit time. So as you go through the night, you'll get, the transit time will progress. I also have some composites that I've put together to try to do and everything, and those are listed in here also. But so that's an awful lot of information. This has, I don't know how many pages, 60 pages is typical or so. So what I also wanted to do is summarize in spreadsheet form what the objects were, so it may help me plan the night easier or plan the month. So you can see here the astronomical dusk and dawn, and this is a configuration for, this is hyperstar, nebula, and these are all the objects, nebula type of objects, not a broadband, but a nebula type. These are the objects I highlighted in dark if it's something I've imaged already, and then I have the configuration, the class, the type, the object name, imaging window, transit time, and the page reference, where it is in this guide, and then comments. So when I go to image for a night, this is what I'll look. I'll say I'm going to do a hyperstar configuration. Okay, what would be the objects I want to do? Well, I can get, if I want to do this object, I have got from 8 o'clock roughly to 2 or 3 in the morning. Okay, and then do I want to image anything else? Do I have a time slot that I can do something in here also? And then I'll go ahead and plan that. So that's for hyperstar, whatever they call it, nebula, and this is for broad spectrum items that are in the list. And then we got the focal reducer nebula, and then broad spectrum for the focal reducer, and primary focus. And then finally, this is, again, for my personal usage, but kind of an idea of giving you guys an idea how to use it is, where's that? My imaging, we're still on project, there we go. My imaging plans. So I'll say, if I want to do hyperstar one night, this is the objects I think I can do and the timing of it. So these are the 3 objects I could get. But if it's windy, maybe I want to do a focal reducer or something like that. And this is what I want to try to image this one. So that's basically how this works. And we're almost out of time. So let me show you the Telecopus website real quick. And that's here. I'm going to also put this in the chat. This is great. If you guys are not familiar with this, you should definitely look at this if you're planning on doing some imaging. You can type in the object you want. You first log in, type in the object you want. Let's say I want M42. Put it in there. It'll find it. And then you can come in here and say, I want to see what it looks like in my hyperstar configuration. And here's the hyperstar. You can move it around. It shows you the coordinates. You can plan mosaics if you want with it. You put all your hardware in here. And it's just a wonderful little tool for planning your imaging session. So anyway, I wanted to show that to you also. And that leaves me a couple minutes left. So I think I'll go ahead and entertain any questions if anyone has something they want to ask.
Okay, thanks, James. So Pat, could you put your question in the Q&A? And just for everyone else, James, you were putting in the chat the host and panelists. I echoed that to everyone. So when people put something in the chat, make sure you choose on the 2. On the 2, you can choose to send it to everyone or individuals or just hosts and panelists.
Sorry about that. I didn't notice that. Yeah, and the question is, how long does it take me to compile it? Well, now that I've got each month done, what I'll do is I'll go, and first thing I'll do is I'll take last year's and then just update the dates on all of them, and then, or the times, because I need to know when it's going to be maximized. And that's, again, I'll come to Telecopus here and I'll look at and scroll up to see, oh, it's at 45 degrees at this time. So I update that. That usually takes me 3 or 4 hours. And then I'll go see if there's anything else that I've missed, and then compile everything. So generally, it'll probably take me about 6 to 8 hours to put together the each of the months, I would say.
Is that for the whole year or?
No, just in one individual month. You know, every new
Okay.
month I'll redo it again. And so it's not very efficient, but I found it's pretty interesting information. And now that other people use it, I guess it's time spent. Okay, I guess it's good for me.
Yeah. So you don't have it automated. You look up the information and.
Right. I do. You know, like I said, I do take last month's, and that helps a lot. But yeah, it's still manually done.
Yeah, let's see. Yeah, you've got a tremendous amount of information in there. Let's see. So
yeah, there are programs that are pretty good too, but I just found this has, you know, exactly what I need and everything.
Okay, so yeah, we do have a little bit of time. So there's two more questions. Are your hyperstar images single snapshots, or do you do many images and stack them?
Yeah, I always do stacking on pretty much everything, even though hyperstar can be very, you know, good and efficient. And I found, obviously, you know, I'm in the middle of the city, so that's why I broke up the themes as nebula and broad spectrum, you know, and that'll define what filters I use on them.
Okay, and yeah, how many images do you normally stack typically?
Well, I've been changing it. I've recently been trying to set up my telescope in the backyard so I can stack a lot more, right, and spend, you know, days over it. But unfortunately, I've been having really struggled with my mount recently, and so this whole year I've actually been working on that. I haven't really done much, but so I can't really definitively answer that because I also got a mono camera recently and have been trying to do that. When I had the color, I was trying to get at least 2 or 3 hours, but you know, the more time you get, the better. I mean, I've got, well, let me see, I've got one of them that was like 10 hours or something like that. So you just keep getting you know, better imaging, and the more you do it. But yeah, okay. It varies. It depends on how bright the object is.
And let's see, I think Pat Thompson just had a comment that your telescope uses J2000 coordinates. Is that
might be true?
Okay.
I'll be honest with you, I don't keep track of that stuff very much. So
yeah, time flies. And let's see, Walt has a question. As a visitor who's just getting started in astrophotography. Oh, great. Your presentation has sold me on joining EVAC. Incredible work, James.
I'm sorry, what was that? I didn't catch that.
Just reading it from Walt. As a visitor who is just getting started in astrophotography, your presentation has sold me on joining EVAC.
Oh, okay, great.
Work, James.
Thanks.
And Bill Peters, how to contact you. And I think on our webpage. But yeah, do you want to put your email address in the chat?
Yeah, absolutely. I'll be happy to do that. Yeah, and if you guys are interested, like I said, and anyone can contact me anytime. That's fine. Matter of fact, I'm going to retire in here shortly after the new year, so I have a lot more time. When you look at my pictures, if you go to my pictures, it does tell you how, like here on the bottom here, you can see exposure information, 107 frames at 5 minutes each, gain, offset. So it's giving you all the details on how long each of the pictures were. If it was, you know, within the year or two, I've refined the process of what I record and everything.
Okay, and hopefully one of these days we'll get back to live meetings and people can chat with each other in person. That would be a big help. Okay, all right, that brings us to the end of the time slot. Nice job, James.
Thanks, Tom.
And next up we have where'd she go? I don't see Alex at the moment.
Yeah, I don't see her either. You know, she had said that she was having some connectivity issues.
Okay, let's see if we've got a note from her. If not, we'll just go to Sid. Unless she's trying to reconnect. Okay, I don't see the connection. All right. So yeah, we'll move on to Sid, and if Alex can get back on, we'll slot her in after Sid. So Walt, this might be of interest to you also. Sid's going to talk about how to automate astrophotography. So whenever you're ready.
Hang on just a moment here. Okay, just as a quick comment too, James was kind enough to spend some time on the phone with me previously, and I'm one who very much uses his website every month and taking a look at targets in combination with Telescopia. So I really appreciate the work that he does because it was really helpful to me. So let's talk about I look at the three phases of astrophotography. Previously, I talked a little bit about calibrating the data, but there's really capturing the data, calibrating the data, and then creating the image. And tonight, I'm really going to talk about the process of capturing the data and how I approach it and how I try to automate the capture of that data. Basically making it a push button process in utilizing the software and hardware tools that are available. But before you automate a process, you have to have a manual process that kind of fits your particular organization. And for me, it looks something like this. My mount is connected to my hand controller, and I have a laptop that's connected to my hand controller to my mount where the software integrates to that. And before I really get started on imaging in the evening, I really set 3 alarms on my iPhone. I try to image everything above 40 degrees. I'm in Tempe and border lake plus skies. And I found that trying to image below 40 degrees through additional atmosphere degrades the data. So I set an alarm based upon the data that I got from James's information as well as Telescopius about when my target that I'm imaging will be above 40 degrees. I set another alarm on my phone when I pass a Meridian Flip, because manually I want to be prepared to do that, to basically stop my scope and do the reslewing and go to the other side of the meridian. And also I set an alarm every 60 minutes to take a look at the focus and refocus. As temperature changes through the night, as the scene changes through the night, it's really important to maintain very accurate focus. Otherwise, the data that you capture is not really useful. So I'll power on my devices. And the first thing I'll do is cool the camera sensor. Most of the Astro cameras now have the ability to cool the sensor, which greatly improves the images that you collect and reduces the noise. And that's a period that usually takes from 15 to 20 minutes. You want to cool that gradually without shocking the sensor. If I need to, I'll do an alignment on the telescope, check my polar alignment if required, and then I'll slew to the meridian and deck equal to 0. That's a suggested location from PhD2 to calibrate the PhD software for best guiding performance. So I'll follow those directions and then calibrate my guiding software at that coordinates. Stop the guiding, then slew to the target. Once I get to the target, I need to focus in on that, and you can focus with the eyeball, which is not very good. That and off mask works really very well, and it's very accurate. I now have an automatic focuser, which I found is also very accurate, and there are other ways of focusing in, but again, unless your focus is sharp, your data is not good at all. Do a plate solve to center the image, make sure that I'm on target, and then I'll start the image capture. And this involves starting the guiding software, PhD2, setting up the number of images I want to take, the exposure time, the binning, the filters, the gains, and the other parameters involved in the actual image capture. Oh yeah, and take off the lens cap. I'm sure that none of you have done this and started an imaging session or starting an observation session and left the lens cap on. So that's a very important feature. Most times when I'm imaging at a target, I'd like to have it available for 2 or 3 or maybe 4 hours or maybe longer. And if I have a good night and I can image all night long, I want to image all night long. So that usually entails trying to image more than one target, sometimes 3 targets in the evening. And that's the case, I'll stop the guiding, I'll stop the capture on the first target, slew to the new target, and if it happens to be at 2:30 in the morning, I'm out there in the middle of the night with my equipment, refocusing then on a new target. Again, doing a plate solve, starting the capture, and doing the resuming the image capture. And again, as I said, I tried to refocus every 60 minutes. So if I start a target at 2:30 in the morning, I need to take a look at the focus at 3:30 in the morning and maybe 4:30 in the morning. So basically, it's an all-night affair. If there's a meridian flip involved, what I want to do is be able to stop the guiding before I reach the meridian, usually wait about 10 minutes for the target to cross the meridian over to the west side, then resalute to the target, refocus, replate solve, restart the guiding software, and starting the capture, and then resume that monitoring process again and checking focus about every 60 minutes. So again, hand controller is connected to my mount, connected to my laptop, really requires constant monitoring. If you're imaging all night long, we all know that sometimes there's a lack of sleep involved. And in the winter here in Arizona, it gets cold. And I've been here a long time, so I'm definitely a desert rat. And I'll find myself out in the backyard with a down vest and a parka and fingerless gloves on and a red light on my head and a stocking cap and maybe electric socks. And it's cold. It really gets cold at night out there all night long. In the summertime, we have the boiling desert nights. When the sun goes down, it's often above 100 degrees or 45 or 40 to 45 C. It's difficult to cool the camera. The scope is hot to touch. The chair's too hot to sit on. I'm sweating on the keyboard. Snakes are prowling around the backyard. And it's really difficult. It's severe condition. So what can you do to avoid some of that? Well, you can replace that with one button. And how do we do that? Well, there's several tools available to do that. APT or Astrophotography tool has been around a long time. It's a very good tool. It's well proven. It works well, and it's very, very reliable. It's more of a command line type of a thing. So you have to be able to identify those manual steps and basically write those manual steps into the software. There's also a product called ASI Air, which is basically an embedded microcomputer. Oftentimes it's a Raspberry Pi function, and it integrates some of those hardware and software tasks of integrating and capturing the image. I tried it about a year ago, and that particular version I found had some difficulty with longer focal lengths as far as plate solving and guiding. But since that point in time, there's been several new issues that come out, and I think now that's probably very, very good. And for automating the process, it's probably a very good avenue to take a look at. SGP or Sequence Generator Pro has been around a long time. It's very modular, very powerful, very configurable. You can also control your observatory windows. You can hook it up to a weather station and look for dust storms and lightning and other types of things. So it's very, very functional. It takes a little bit of programming and then putting that together. Most recently, there's a program that came out called NINA, which is called Nighttime Imaging and Astronomy. It's an open source program, and you can really tell it's been written by a programmer. And if you've ever done any programming, it looks very, very familiar. It's very graphical, and it's very kind of point and shoot. And I found it takes a little time, but it's very easy to understand and learn how to program. Automation. My original attempt at automation looks something like this. My telescope is connected with a cable to a USB hub, and then all my equipment is connected to that USB hub, which talks to my computer, which talks to the software. So the cameras, the mount, the focuser, everything that's on my system is connected to the hub, which is connected to my computer. Well, that requires you to be at the telescope for setup and monitoring. Also, my laptop is outside all night long. And originally I found that by the time I went out in the morning, I often had a layer of dust on my laptop. I found I had to protect it with some type of covering or something to protect it during the night, especially if there's a rain shower or something that comes up. And plus you have to constantly go outside to check on the status, make everything is working, take a look at the software, make sure that your scope is functioning properly and you're in the right area and catching the image. The second approach, my laptop now sits inside. It's connected to my Wi-Fi. I've also included a Wi-Fi repeater. This is about a $20 or $30 item because once you go outside your house, typically your Wi-Fi disappears. And this pumps up the Wi-Fi so that about 50 feet in my backyard, I can talk to my system. And my system really includes, this is a Windows 10 computer. Intel refers to it as their NUC, or the Next Universal Computing. But it's just a small Windows 10 computer. There's a variety of people that manufacture that. The one that I use is manufactured by a company called B-Link. And it's a computer. All my equipment is connected. This is my USB. All the equipment connects into the USB ports on this computer. It has Wi-Fi, which talks to my home Wi-Fi, and it controls everything on my computer. So basically, I can sit now in my house over my Wi-Fi and have all that control and sit inside. So what that allows me to do now is basically I can push that button, start my imaging process. I can watch my 3 series of FBI programs that night. Occasionally, I can look at that remote desktop program. And if everything is going well, I'll just go to bed. I'll wake up in the morning and I'll go out and collect the data from the imaging session. So I'm doing a couple of things right now. And I wanted to show you a particular target that I did image. And it was a narrowband image and a color image. I had previously collected some color data on the PACMAN Nebula, NGC 281. And of course, the visible spectrum ranges from about 400 nanometers to 700 nanometers. And it goes from the violets into the bright reds. RGB is a little bit more difficult to image, especially in my Bortle 8 skies because of all the light pollution efforts. And especially if the moon is up, it's difficult because the light from the moon really swamps over the data that's available. Most recently, I've been experimenting with a mono camera and doing a lot of narrowband imaging. And the primary elements in an emission nebula are oxygen at 501 nanometer, hydrogen alpha at 656, and sulfur S2 at 672. So by using the SHO filters, you can select a very narrow band of light, eliminate all the problems of light pollution, and basically collect the data that you're looking for. This particular one, of course, most people are familiar with, which is the pillars of creation. In the Hubble palette, they talk about the Hubble palette being SHO, which is the sulfur filter, the hydrogen filter, and the oxygen filter. So this particular evening, I'm going to image the PACMAN Nebula, and the moon was up until about 12:30 that night. So what I planned on doing is I'm going to shoot color data or RGB data until about that point in time when the moon drops below about 20 degrees and starts to fade. And now I can start shooting RGB data. So I'm going to start out by shooting narrowband data. And this is a kind of a screenshot of what Nina looks like. And it's very basic in the fact that there's a global trigger that this always looks for the position of a meridian flip. And then Nina, you can define what's supposed to happen when you approach a meridian. There's a start and an end, and then this intersection is basically the data collection. So if we look at what the start does, I unpark my scope, set my tracking, and this particular is a function of Nina as well. It can send a text to your iPhone about where you're at in the process. So when I start cooling the camera, I send myself a text that says the cooling has started. I cool the camera, and it's usually a period of about 15 to 30 minutes. When the cooling is finished, I also get a text back saying that the cooling is finished. And what I'm looking for here is to make sure that I've taken a minimum amount of time to cool that camera, so I'm sure that I'm not shocking the camera by trying to cool it too quickly. I changed my filter to a luminous filter, which is basically an IR cut filter. I changed my focuser to position 56,000, which on my focuser is the mechanical position, which is pretty close to focus, depending upon the seeing, depending upon the temperature. I know if I start there, I'm pretty close to a good focus. I'll slew to 185 degrees at about 30 degrees altitude, and then delay for about 10 seconds and wait for things to settle. Now, the next statement is really a functional statement. It's about astronomical dusk. In this particular evening, that occurred at 48 minutes and 1 second after 6 p.m. What that allows me to do is that earlier in the evening, when about 5 o'clock or so, I'll go out, take the cover off my scope, take off the lens cap, make sure that happens, make sure I'm all ready to image, and I'll just say start. And it will go through these particular steps until it gets to this point. So now my camera is cooled, I'm ready to go. When I get to 48 minutes and 1 second after 6 o'clock, I'll go to the next step and continue with the process. And here the next step is I'm going to slew to 60 degrees at the same azimuth. And what this does is that it eliminates the backlash for my next steps. So now the gears are engaged, the backlash is taken out of the system. I'll now run an autofocus to make sure my stars are nice and sharp. I'll start guiding calibration, let PHT2 run through his calibration routine, and then complete that. When that's finished, I also get a text that says now PH2 has completed calibration, and I know I'm ready to start imaging. And starting imaging looks something like this. This is the RAN deck coordinates of my particular target, and it also displays a time versus altitude as from astronomical dusk to astronomical dawn. This can be obtained via Nina via their Sky Atlas, which is a fairly complete atlas of a lot of celestial objects. And also this button will allow me to connect to Solarium. And if I locate the target at Solarium, I can click this button. The RAN deck coordinates will be brought into Nina. The quarter will be brought into Nina. I'm all ready to image. I'll then slew to the target and center the target with plate solving to make sure I'm on the target. I'll start the gouting this time. So I'm ready now. PH2 is running. Again, I'll do an autofocus just to make sure I'm in focus. I'll go to the luminous filter, which is the clear filter, move the focuser to my node position, which is fairly close to focus, run the autofocus again. And once again, when that's finished, I get a text on my iPhone that says slew and focus is complete. I'm going to begin capture. So now I'm going to capture narrowband data. And I'm going to capture that up until the point in time when the altitude of the moon is a little bit low 20 degrees. So the moon is in the south, my target's in the north. When the moon drops at that point, I will not be able to switch over to RGB. But until that happens, I'm going to image in narrowband. I'm going to take 4 exposures at 300 seconds of the S filter, 4 exposures of the hydrogen filter, 4 exposures of the oxygen filter, send myself a quick note to my iPhone that says I've completed these exposures. And this will continue to loop over and over again until this particular parameter is met. So when the moon is now below 20 degrees, this will stop imaging on the narrowband. I'll get a message that says LRGB is going to start capturing. I'll drop over to the next phase. And this is now going to capture my LRGB data. Now it's about 12:30 at night. The moon has disappeared, and I can more comfortably capture full color data. I'm going to take 12 frames at 60 seconds of luminous, 2 frames of the red filter, 2 frames of the green filter, 2 frames of the blue filter. And when that loop is complete, I'm going to send myself a note that I've completed 1 loop. Now this loop will continue exposing until either the altitude of my target drops below 40, which I said before is that I don't like to image below 40 degrees because of the corruption of the atmosphere, or until astronomical dawn. And this particular day, dawn occurred at 53 minutes and 8 seconds after 5 a.m. So whenever one of those 2 conditions is met, I will stop imaging. I'll drop over to the next phase, which is basically closing down the system. I'll park the scope, disconnect the guider, disconnect the filter wheel, disconnect the focuser, disconnect the rotator, disconnect my telescope. And now I'm going to warm the camera. The same thing occurs when I'm warming the camera. So when I'm cooling the camera, I want to make sure that occurs within 15 minutes to maybe 30 minutes. Again, not to thermal shock my sensor, make that nice and smooth. When that's complete, I'll disconnect the camera and I'll send myself a text that says, okay, sequences are complete, shutdown is complete, and good night. So I'm through imaging that particular night. So I'm complete. And one of the cool things about NINA is that it's open source, which means that individual raw amateur astronomers and programmers are continually writing modules that are made available to all the users. And all the check marks are the ones that I've downloaded and used. And I really won't go into those tonight, but one I want to show you is the Scope 3D view. And there's a Green Swamp server system, which you can add on to your software, which will show you the position of your scope. So this now gives me a visual representation of where my telescope is pointing and what direction it's pointing. So at any point in time, I can take a look at that and kind of verify that, okay, I know where my target is. I know my scope is pointing basically where it's supposed to be. I'm collecting data. My data should be good data. But those other modules that you see are also very useful, and I use most of those myself. So again, automating the astrophotography process, it's basically a 1-button process, utilizing any of those software tools that I mentioned before. But again, I utilize NINA. I found it very useful. So again, I can go back and watch my favorite program. Occasionally, I can take a look at my computer sitting inside to see the software, what it's doing. But really, the most important thing for me right now is that I continually get these text messages. So as I complete those loops of image capture, I get an update. And as long as I'm getting these updates, I know that my system is working, that I'm capturing data. In this particular case, I started on a galaxy cluster of 2666. And when it moved below 40 degrees, I moved to the next cluster of 4226. And that was complete, and I shut down in the morning. So basically, I was able to image about 7 hours that night and collect a lot of data. So I go to the bed, wake up in the morning, and go collect my image data. So now there's a downside to that, in that this process is working really well, so that I can basically go out and any night I want to set up my targets, utilizing some of James' information as well. I can set up 2 or 3 targets, collect a lot of data. So what I found myself in right now is I've got about 10 sets of data on various objects that I haven't gotten to yet to start processing. So I'm collecting a lot of data, and I'm getting ahead of myself as far as processing the individual items. So again, looking at the automatic process, it's basically a 1-button process. Once you have your manual process set up, and you can basically write it into that particular piece of program, and you can collect a lot of data. Now, most recently, I mentioned I'm doing some narrowband imaging the S, H, and O filters, and basically doing some Hubble palette image generation. And I just recently shot some images of the Bubble Nebula, which is a target I did about a year ago in full color in RGB. And this time I shot it in S and H and O filters. And I just said, well, what will happen if I just process that in the H filter and the O filter and make it an HO process? Well, what I wound up with was the Christmas bubble, I call it. And it's a ho, ho, ho. I think it's appropriate for Christmas. So basically, Merry Christmas, Happy Holidays. And that's the end of my presentation. So again, thank you. If you have any questions, be happy to discuss anything with you that you like. I'm always interested in talking to other people about what they're doing, how they're doing the photography, the equipment they're using, and ideas. You can get me at sid.frede@cox.net. Happy to converse with anybody who wants to have a chance to talk about what they're doing.
Thanks, Sid. That's pretty cool. We've got a couple of questions in the Q&A. One was, do you use Nina ground station for text messages?
That is one of the modules that is written into Nina. And all you do is basically download that module, execute that module, and then set up your text messaging. You can set up text messaging, email messaging, IFTTT, various types of interface.
Do you actually use that though?
That's what sends the text messages to me.
Okay,
I go through the process.
great.
Yes.
Let's see, the next one from Wayne. What's the name of the small computer used in conjunction with your router?
It's called B-Link as a manufacturer. It's basically a Windows 10 computer. And if you go to do a search on those, you'll find a variety of manufacturers of all different configurations. But it's a fairly simple Windows 10 computer. You don't need a lot of processing power, and it's fairly inexpensive.
Okay, I think James had one in the chat. Now let's see, do you find you need to refocus for each narrowband filter?
That's a good point, in that Nina has the ability to do a filter offset. So you can run the program and it will, you can pick the primary filter. In this case, I picked luminance, and it will go ahead and run 3 iterations of every filter and find an offset. So anytime you switch a filter, it knows what the mechanical offset is on the focuser, and it will adjust that without doing an autofocus. Saves a lot of time.
Okay, great. And just a reminder to everybody, if you think of a question for one of the previous speakers, please throw it in the Q&A, and we'll get to it at the end of the presentations. All right, thank you very much, Sid. Nice job.
Thank you.
And Alex's computer is now working again, so we'll get a nice presentation from Alex. So go ahead, Alex, whenever you're ready. And Alex is our new treasurer for EVAC, as you might have remembered from Gordon's slides.
All right. Can you guys hear me okay?
Yes.
Okay. I apologize if you hear any dogs barking in the background. They're being quite loud. All right. Let me get this started. Yeah, I was having a little bit of computer issues. Hopefully getting a new computer soon. But today we're going to discuss some exciting things about processing Hubble data. So this data is available publicly. Anyone can download it, and it is such amazing data. So you probably know of the Hubble Space Telescope, quite a famous telescope. I actually just got into astronomy a couple years ago, so I didn't know much about it, but lately I've gotten to know it very, very well. So these are some images from the Hubble Space Telescope that I have processed, and these are all downloaded for free, and you can just process them on any type of software that you have, like Photoshop or PixInsight. There are so many beautiful images that can be downloaded and played with or used for scientific purposes, but I am not an astronomer professionally. So before I get into the processing of Hubble images, I wanted to kind of mention Webb real quick. I'm also a NASA Solar System ambassador, so we do public outreach, and very, very excited for this telescope launch. I hope that you guys get to see it. December 22nd will complement Hubble in many ways and expand upon what Hubble can do. So just to give you guys an idea of the differences between Hubble and Webb, Hubble is a pretty massive telescope. Its primary mirror is almost 8 feet wide, which is just massive. But then the Webb telescope is going to have a 21-foot wide mirror. So we are tripling that stargazing power, and we are just sending this massive folded up telescope into space. So I really am excited for the launch and hope that it goes well. So Webb is going to have 4 science instruments. They probably look familiar, such as like the camera or the spectrograph. Hubble has similar instruments. Only the difference is that Webb is going to be imaging in near infrared and mid infrared wavelengths of light, whereas Hubble sees mostly visible, a little bit of ultraviolet, a little bit of infrared, but kind of sticks with the visible wavelengths of light. So to kind of give you an idea of what Hubble might look like, let's say if we're imaging a nebula, the image with the kind of rainbow hue, which is totally not scientifically accurate, but very pretty. It's invisible wavelengths of light, so very dark, can't see anything. You can maybe see a couple of stars poking through, but we kind of just see mostly that gas cloud. Whereas when you can image it in infrared wavelengths of light, which this is near infrared wavelengths, also taken by Hubble, but you can see just how much we're able to pierce through all of that really thick gas and dust to kind of see what's inside the nebula. And a lot of these stars are actually behind the nebula, but it will allow us to really kind of see if we can see things like star formation that usually happens around really thick clouds of gas. So here's another example of an image taken by Hubble in visible length and near infrared wavelengths of light. So there's just such a vast amount of stuff that we can see that is really obscured. So pretty exciting to see what Webb is going to give to us. But what about Hubble? We're not just going to like cast it aside the minute we launch Webb. It does have a potential decommission of 2030 to 2040. Really hoping it just lasts as long as it can because I love Hubble and the data and it's so cool. So really excited to see what happens with Hubble as time goes on. And before I kind of dive into a bit of the image processing and how it can be done, just wanted to share this short little video about Hubble and Webb and how they will complement each other. All right, so very, very excited for that launch, and hopefully the database will, for Webb will be just as easy to access as it is for Hubble. And I will be putting all of the links to these archives in the chat box at the end, so you all can download them too. So all these pretty pictures from space come from black and white images. And most of you are probably familiar with that narrowband imaging and using different filters and the monochrome camera. So Hubble only images in black and white monochrome. There is no color. We add that post-processing in a program like Photoshop or PixInsight or whatever program you use. So the famous antenna galaxies is my example. And this is taken in the visible wavelengths of light. So this is really that rainbow that we can see with our own eyes, you know, red, green, blue, purple, whatever. I mean, technically we could color the image anything we wanted, but we prefer to kind of keep it natural and mimic how our own eyes would see. So we are going to color them red, green, and blue to kind of mimic the red, green, and blue cones in our eyes. And when you download data from the Hubble Legacy Archive or the MAST portal, you will get different filters which correspond to different wavelengths of light or elements, depending on kind of what filter they're using. So the first image that I downloaded is for the 814 nanometer filter. This is closest to the red color of light. It actually kind of gets into near infrared color, which we can't see, but we just color it red to kind of mimic that red color. The next filter is 555. That's kind of close to a green color. So turning this black and white image into green. And then the third filter is 435, which is close to the blue-violet range. So we color it blue. And you might notice that these filters actually do kind of seem to capture a little bit different elements in each image. Some of them correspond to different things like O2 or hydrogen alpha. I don't know the specifics on that, so I'm sure if you're familiar with it, you can easily figure it out. But 658, I do know that is a hydrogen alpha filter. It's kind of close to a red color, so we also color that red. Most data sets are about 3 filters, red, green, and blue. Some are 2, some are 4, some have more. Kind of depends on the data set. I mean, they collect this for scientific purposes. I just like to make it pretty and have fun with it. So by combining all 4 of those images together and enhancing the photo in many other ways, I can create a full color image using data from the Hubble Space Telescope. So super duper exciting and so much fun to play with. And what's actually really cool about it is the more that you process, you actually start to learn kind of what different features look like. For instance, galaxies, often this blue color will symbolize young star clusters or newborn stars. Often we see this in colliding galaxies, which usually have starburst phenomena and a lot of newborn stars. The red is usually nebulosity, where there are also nebulous areas and newborn stars being created. The brown is usually dust, and yellow is usually the core of the galaxy, where the older stars are. So it's kind of cool when you process a lot of them and you can start recognizing different features of a photo. But it's not just, combining different colored photos. There is so many steps to it, kind of depending on your data and how well it is. We colorize the image, we can stack it or enhance the colors or do contrast enhancement, kind of just a bunch of different things to make the photo look good. Most of the data from Hubble is really good. There's not a lot of noise in it, but some of the older photos need a little bit of extra work. So to kind of show you that in a complete picture, this is what this image would look like from each filter. So you have your 4 black and white, color each filter, stack them all together, and get your beautiful final color image. This is actually the first image that I ever processed from Hubble, so it has very special meaning to me, and it's what really got me into downloading this data, and it's just so stunning. I love it so much. So before I end this presentation, I wanted to kind of show you the whole process from start to finish, as well as go over the 2 data archives. And I do also have tutorials, and I can put those links in as well. So the Hubble Legacy Archive is the main archive. Well, not the main, it is the easiest, at least in my mind, to download data because you can easily look at the images and preview them before you download them. But it's called also an older archive. So it doesn't always have the newest images available. But that is the MAST portal, and that has not only Hubble data, but a few other NASA telescope data as well. I know one of them is Spitzer and a few others. So you can use this portal, which is pretty much the most up-to-date portal, to download that data and process these images. So I will put those links in the chat and start this little video to kind of show you the whole process from start to finish. So it does go kind of fast, and I'm not really going to explain what's happening, but if you have any questions, feel free to ask. All right. So that was a very quick introduction into downloading things. Well, not downloading, but how we process Hubble images and can create really pretty pictures, or if you know how to use it for scientific data, that's really cool. So thank you guys so much. And if you have any questions, let me know and I'll get those links in the chat box for you.
Oh, thanks, Alex. Let's see. Gallery. Yeah, any questions? I just remembered that the panelists can't actually ask questions in the Q&A. So the panelist has a question, please put it in the chat and hopefully we'll find it. Let's see. Yeah, their last processing speed was super fast. You only go half that speed, right, when you're doing your normal work.
Oh yeah, some images can be really fast and some of them take a couple hours depending on how much detail you want to go into.
That's pretty cool. Yeah, we'll try and provide links to the steps Alex followed to make to color those various layers of the image. Oh, Alex, I did have a question. What format do you get the Hubble images in? Is it TIFF or?
Yeah, so that is one thing I totally skipped over. They do download as FITS files, which I believe
okay.
if you're into astrophotography, you're probably familiar with. But then they do have a converter created by NASA and a couple other companies that converts FITS into TIFF so you can work in Photoshop. So.
Okay, that's good. Yeah, that sounds like a fairly raw file. Okay, again, some kudos in the chat. Same with our other panelists. All right, thank you, Alex. That was a really cool presentation. And we'll move on to John. And John's internet isn't the best, so I'll be the file flipper for John. Just have to make sure John unmutes. You ready, John? You're still muted. There you go.
Can you hear me now?
Yeah, I can hear you. So I'll put your presentation up. Make sure we've got the right copy. Okay. Move myself. The wrong one, sorry. I'll try it again. Share screen. Go into presentation mode.
Go ahead and start that. When I started out, I was taking my telescope out and I'd have to polar align it and go through quite a lengthy time getting set up to do either observing or just some imaging. And I also, when I was imaging, it seems like a little gust of wind would come along and upset my image, and it was just a problem. So my wife, bless her, decided that maybe I should build an observatory. And so I started researching various observatories, and thought because we were going to locate the observatory up near Sholo, it's much windier up there than it is down in the valley. And we had a lot of wind there. And I thought that a domed observatory would give me some measure of protection from the wind, and I'd be able to image or observe with the dome shielding the telescope from the breezes. So I went through a number of things. Tom, if you want to go to the next slide. I went to look at a number of domes, and most of the domes that I saw were much larger and obviously much more expensive than an Explorer dome. And so I started doing some research on Explorer Dome. They had an extensive website, and they had several examples of how you might either purchase the entire package or just the dome itself, and they had plans and various things. So as you can see, this example of an Explorer Dome has a little miniature door, and you go in and you stand up, and really didn't have what I really envisioned as my observatory. So I used the plans that they have for some of the other things and expanded on it to come up with a design for my observatory. So next slide, Tom, please. With dealing with Explorer Dome, they're located in the Midwest, and I was going to have to pay shipping to get the dome sent down to me, and that was going to be quite expensive. So I found out that Stellar Vision down in Tucson is a dealer, and they actually had an 8-foot dome in stock, and they had it all rigged and on a trailer. And so they let me borrow their trailer, and I towed it up to my site, and I avoided all the shipping charges. And if you're not familiar with Stellar Vision, I'll give them a quick plug. They're an astronomy and science shop down in Tucson. They sell telescopes and a lot of other things, and they're very nice people to deal with. Next slide. This is the site. You can see we started with a foundation, and you see there is a handyman that I hired to assist me with the project when 2 hands were required. The foundation that I laid out was 12 foot by 16 foot, which is under the limit for having to have a building permit. So it was very convenient that it worked out that size. You can see we prepared the forms and getting ready for additional work. Next slide, please. This is the pit for the pier foundation. We were digging down. We were going to initially have it as a 3 foot by 3 foot by 3 foot cube. And the ground was so hard that when we got down to about 2.5 feet, we couldn't get down any deeper. So we ended up making it a little bit wider, 4 foot by 4 foot, and it's just over 1 cubic yard of concrete. Next slide. You can see here, everything's ready. The rebar is in place, and we're all ready to pour concrete. Next slide. Instead of mixing the concrete by hand, we ordered 4 yards of ready mix, and that proved to be a lifesaver. We had all that concrete by hand. It would have taken us forever. Next slide. You can see in the middle there's a square of foam insulation. And I use that insulation to form an isolation and a vibration damper between the floor of the observatory and the foundation of the pier. So that's very important to have all the sources of vibration isolated from one another so that when your telescope sits on your pier, there's no vibrations from anything else. Next slide. We also took some additional measures to isolate the pier from the foundation. We put a big collar around that, so when we poured the foundation, the floor foundation wouldn't touch the where the pier was going to be. Next slide. This just shows us pouring the foundation and screeding it off, and it took us a couple hours to get all that going. Next slide. See here, it's all already poured and finished, and you can see the little studs that are around the perimeter so that we could bolt the framing to the foundation. Slide. You can see here we're starting the framing. I use standard 2x4 framing construction. We'll go through these slides pretty quickly because you'll see how we progress. Next slide. Just another slide of the walls going up and being bolted to the foundation. See the Explorer dome there. Look closely here. This framing, I use 2x10s to carry the load across the walls, and then 2x8s on the sides, and 2x6s for the 45s. And that is the design that I got from Explorer Dome on that. And I just increased the size of the lumber to account for the larger span that I was having because I built the observatory much larger than their plans were. Next slide. You can see that the 2x10s are also carrying the framing for the roof, and the framing is continuing there. Slide. The framing is almost complete here. You can see the dome awaiting mounting on the roof. Okay, slide. The siding goes on, and we're just continuing the process. Next slide. See here the what they call the dome ring. That's the ring that the dome will rotate on, and you can see the bracing there. That's to keep the dome ring true to circular, and the metal clips is how it's attached to the framing. Slide. In order for the dome to roll properly, it has vertical and horizontal rollers spaced evenly around the perimeter of the dome ring. And there's a track on the dome itself that those sit in. So the weight of the dome is supported on that, and the guides that are in the horizontal keep it on track so that it'll rotate properly. Slide. We didn't want to hire a crane because it was very expensive. So we laid out several boards, and we used a 1,000-pound come along to start advancing the dome up to the top. So next slide. See how we ratcheted the dome up the boards, and then when we got to the next slide, you'll see we got to this point, and we were stymied by not being able to affect the incline. So the next slide will show we got some ladders involved and eliminated the incline, and we're able to dome all the way up on the roof with the ladders. Next slide. Once we got there, the dome was almost in place, and the two of us were able to lift with a lot of problems, but we were eventually able to lift the dome up and put it onto the rails and get it onto those guides. Next slide. So this is a picture from inside the dome. You can see the bracing still in place, but the dome is in fact in place. Next slide. Had put the roofing on. Once again, I just used the composite roofing, roll roofing. Nothing fancy. Next slide. Okay, here we are. We're all framed, sided, domed, and roofed, and we're ready to start working inside. Next slide. The next thing, this is preparing to pour a 12-inch concrete pier from the foundation that we saw earlier. 10 inches probably would have been sufficient, but I thought, well, if 10 inches is marginal, we'll just go 12 inches and remove all doubt. So you can see we had 12-inch sonotube, and we slowly worked that up to the proper height. Next slide. This is the top of the pier, and next slide will show the final slide, Tom. This is the top of the pier, and I used a pattern of 6 3/8 inch, 5/8 inch threaded rods for the to put a platform for the telescope to mount on. Slide. You can see here I'm starting to frame out the steps that goes up to the what I would be ultimately having an observing platform. So there's steps of 3, and then there's a platform, and then 5 steps up to the observing platform. Next slide. See the framing for the observing platform, and the pier is actually coming up through that floor. Next slide. Here you can see I have a little trap door that you come up the stairs to the observing platform, and you can see the top of the pier there. Slide. Another view looking out the other way. You can see the door from the observatory into the warm room and then outside. So there's 2 doors out there. Slide. This is the picture of the warm room, and you can see I'm doing the electrical things. I put a lot of electrical outlets in the observatory so that I had power anywhere I could think I might need it. Next slide. This is my Celestron 11-inch, and it's installed on the CGM mount. Slide. See here, I'm framing out for the desk in the warm room, and so I have a desk in there and with a computer and things of that nature, so I can stay in the warm room and control the telescope in the observatory. Next slide, please. There's a light installed in the warm room. See the door to the outside and the door to the observatory. Next slide. This is the observing deck, the platform all completed. You can see there to the left how I use threaded rods to hold a large piece of oak that I laminated together to form the base for the telescope to mount to. See the trap door for the steps there as well. Next slide. And the final part of the project is I ran electricity out to the observatory to the house, and so now originally I didn't do this right away. Originally, I had an extension cord that I would just plugged into the house and plugged into the observatory to get the electricity out there. But finally, I just went ahead and put permanent power out there. So next slide. In summary, we started the project in September of 2011. And the first light was about 9 months later. And the reason that took so long is that that's our second home, and we weren't up there all the time. So I worked in fits and starts on the observatory. Cost was just over $9,000, but I don't regret spending that money at all, because you just can't beat going out there and flipping a couple switches and entering the date and time on your telescope mount, and you can immediately start observing your imaging. So that was the building of my Explorer Dome observatory.
Thanks, Sean. That was good. We have some time for questions if anyone has some questions. It's quite a project. I'm kind of envious.
That was worth it.
Definitely. So I think maybe our audience is questioned out. Oh, here we go from James. Nice looking. Is your dome manually moved?
It's manual. I have not automated it. There's some plans to do that. Use a garage door opener with a cable to spin it around, but I've just been using it manually myself.
Okay. Here's one in the Q&A. Let's see. Why did you want the telescope raised so high?
Well, if you noticed in some of those pictures, there were a number of bushes there, or small junipers. And the wife didn't want me to cut down any of the junipers, so I wanted to get it high enough so I wasn't having the junipers in the way.
Okay. Any other questions? Where is the telescope located?
It's up near Shola. It's at 7,000 feet. In the White Mountains.
There we go. Let's see. Any more? Any for previous speakers that you thought of along the way? All right. Thank you, everybody. Those were 5 wonderful talks. You know, turn the meeting back over to Gordon, and congratulations, Gordon, and thank you for 2 years of being president. That's no easy task.
All right, good. Hello, everybody. Hey, all the presenters. If you guys can hear me okay there, Tom?
Yes.
Yeah, all those presenters, great, man. This was a great idea that we had that do something special for December, since we can't get together. So some great presentations. I mean, this was really cool to hear, to listen to our folks talk about what they're doing. And I hope this prompted some of you to get involved a little bit deeper with what we're doing, and also get involved with the club a little more. Do some member presentations. You can see how good these are. And if you have any adventures that you want to share with us, make a member presentation or write a little article for our newsletter. That's why we're here. So I want to thank everybody for the last 2 years on supporting the club and supporting me and making sure that I do my job, which was easy because as president, I say all I have to do is make sure everybody else does their jobs, and everybody, all the officers had done their jobs fantastic throughout the last 2 years through these troubled times. So I want to thank them, and thanks for the membership hanging in there with us. You know, we'll eventually get back together, and when we do, boy, it's going to be a big celebration for some in-person activities that's going on. And Claude, I'm wishing Claude good luck. You have some great people supporting you, and you got a great club. So everybody join us again next year in the year 2022 on January 21st, when we'll be talking about Oumuamua. That's that object that the interstellar object that went through our solar system that people were saying, oh, it's aliens, it's an alien craft and all that. So we'll have a professional astrophysicist talk about what that actually was and what we learned from it. So folks, anybody else got anything to say?
Yeah, Gordon, Pat Thompson has a good point. He says, are we going to get a notice of membership dues? Because we might have been lax a little bit before. We used to harp on that, but
yeah. What we've done before is just during our meetings, we publish them all out, and yeah, we really haven't decided yet about how we're going to handle next year's dues, on how we're going to get out to everybody. You know, the last 2 years is kind of loose, but we'll see. I really don't know for sure, and that would be something that Claude would propose to the board, And
No,
then,
Alex is our treasurer and Claude's our president. Maybe do either one of you want to weigh in on that?
yeah, I don't think we have anything online yet, everybody. So all I can say right now is yes, there will be dues. Of course, we still need to pay dues, get this keep this club going. But I personally don't know exactly how we're going to get it out to the public. So hang in there with us, and we will.
But you can always mail them in.
Yeah, right. You don't have to wait for us to twist your arm. You can always go to the website, and there's a place to mail them in.
Yeah, we do take PayPal, or they can be sent, like you said, to the PO box that's listed on the website.
Yeah. So anything else from anyone else? Any other questions that we have? Any comments from the panelists? And thanks for those great member presentations. That's our club. That is our club doing its best. Okay, then guys, thanks again for supporting me for being the president. And I'll give the usual countdown and say happy holidays and a happy new year. So 3, 2, 1. Bye, everybody.